So hello everyone, I would like to welcome everyone to our Architects Focus presentation today. It's my pleasure to introduce Alicia Colon, who works for Stephen Winters and is a New York Passive House volunteer and will guide us through today's presentation. So Alicia, it's all yours.
Yes, thank you, Andreas. Hello, everyone. My name again is Alicia. I'm a volunteer with New York Passive House, and I'll be introducing our speakers today. I want to first thank you all for joining us for this week's Architect Focus, Never Demolish in New York City Innovative Strategies. So today we will hear from Paul A. Castrucci, architects, Passive House design firm. They'll be presenting two deep energy retrofit projects, discuss their challenges and design strategies for a cost-effective retrofit solution. I would also like to thank the Paul Castrucci architect firm, who has been a sponsor of New York Passive House for many years. So without further ado, Grayson and Ashok, you may take it away.
Sure. Thank you very much, Alicia, as well as Andreas, for hosting us today. And thank you, everyone, for joining with us today. So Grayson, who is a partner at our firm, and myself, Ashok, I manage the sustainability aspect of projects in our firm. We're from Paul A. Castrucci Architects. We are an interdisciplinary award-winning design firm, pushing the boundaries of technology, tradition, community, as well as equity. We have a very detail-oriented modern aesthetic with a very strong emphasis on building energy, as well as sustainability. And we're really excited today to share some of our projects and some thoughts on innovative strategies that we are pushing. Next slide, please. So if we look around us, a key component of addressing climate change is the built environment. 40% of global carbon emission, 70% of New York City's carbon emission are from the building industry. So in the coming decade, we have a daunting task to decarbonize our city significantly, and 90% of basically the buildings we're seeing today will have to reduce their operational carbon drastically. So in the following slide, we're showing some graphics to help contextualize the current carbon performance of the buildings, and we're relating that to the United Nations climate goal, which is also aligned with New York City's Local Law 97. So what we see here in red, it shows the carbon emission per square foot for large multifamily buildings in New York City. We're getting this information both from modeling as well as sources from the Mayor's Office of Sustainability in New York. So in the green bars here, what we're showing is the carbon emission cap for 2024 and 2030. So what we find really interesting is the Passive House performance, which is very close to the 2050 standard. And also, when we look at multifamily buildings that are built to current energy code, we get very close to the 2030 carbon level sort of requirements, but we're not quite there yet. And we have a lot of examples of buildings built to Passive House standards. The New York Passive House community itself has been exceptional at pushing Passive House and energy efficiency to the forefront. But I think there's a lot of questions regarding the challenge of deploying deep energy retrofit strategies on a very, very large scale. And so how do we address some of these issues that include electrification of buildings, integration of different mechanical systems, while also respecting the existing socioeconomic as well as architectural context of the building? So in this presentation, Grayson and I will discuss challenges and also upcoming technologies and cost-effective, as well as scalable strategies to achieve deep energy retrofit at Passive House level. There are many, many reasons why we want to retrofit instead of build new. So why would we do it instead of building a new building? Well, one is energy, carbon, cultural, architectural, and social. So let's talk a little bit about embodied carbon. What we know is that the embodied carbon is a huge piece of the puzzle in combating climate change. Here we see in this graph, business as usual, where new construction, where 49%, basically half is embodied carbon. embodied carbon is even more urgent than the total accumulation of carbon of a building over their lifetime. So, you know, when we look at standards like PASFA, it's really good at addressing operational carbon. And as we start moving towards more and more energy efficient standard like PASFA, we start seeing that the carbon emission over the building's life cycle, the embodied carbon becomes very, very critical and the next thing to address. And time is also a very critical component here. You know, we recognize the need to hit carbon reduction threshold by 2024, 2030, and 2050 to avoid like the most disastrous scenarios in terms of our climate. But in this scenario, the carbon saved today is orders of magnitude more important than the operational carbon saved in year 35 through 50 when we build to a pass building. So additionally, you know, when we can always reduce operational carbon at a later date, but the embodied carbon, you know, we put in today to retrofit these buildings will be released today, and there's nothing we can do about it. So in this graph, what we're seeing is the area under the curve of embodied energy is weighted very heavily in the years that really matter. And even in our most conscious design, we know that demolition and new construction represents significant embodied carbon, and it's clear that saving existing building is possibly one of the most important tools we have in addressing climate change, as well as adapting to like Local Law 97. We save what we can, and we always build efficiently, both in terms of material carbon as well as operational carbon, both new and retrofit construction. Grayson now will talk a little bit more about some of the urban and social contexts.
Great, yeah, thank you, Ashok. Yeah, so we're architects who are really passionate about energy efficiency and sustainability, and so there can be a tendency by us to get stuck in the weeds, thinking about technical issues. We really love solving technical problems, and we're going to talk about that today. But first, I just want to put a little bit of context. We care about cities, and more to the point, we care about maintaining and improving healthy, dynamic, and vibrant cities. And we all know that the best cities are diverse. They're diverse in their culture, of course, but also in their architecture and urban design. And so the places that we really love to be offer that diversity in size of buildings, and use of buildings, and in style. And sort of one direct indicator of all of those things, size, use, style, is the age of buildings. So we want to preserve cities with different ages of buildings. At the same time, we know the downsides pretty clearly of the sort of tear it down and build it all new at the same time approach. It can be homogeneous, sterile, lifeless. Look, we need new buildings. We really like designing new buildings, but we just want to put new buildings and have them be integrated sort of organically into the context. And with the existing stock, we just want to ask, you know, what is the value of the existing? Can it be repurposed, and can we reuse it? And of course, we know, especially in New York City, the built environment is a big part of our cultural identity and social connection. These are some recently landmarked buildings in New York City that we're showing here. And I think collectively, we all have a desire to preserve and celebrate architecture that ties us to our past and to each other. And so, you know, when we're looking at our projects with our clients and we're debating the best approach, not just whether to retrofit or build new, or possibly both on the same site, but how to retrofit when we find value in the existing conditions. We're of course thinking about energy and carbon and climate, but we're just equally inspired to rise to the challenge of designing for vibrant urban, cultural, and social connections. And we're looking at the work of our colleagues in New York City, Cycle Architecture, Chris Benedict, the list really goes on, inspired by them, and also inspired by people working all over the world. Here we're looking at Lacaton and Vassal. We have just a really beautiful never demolish ethos, which we're very inspired by. And we're just challenged to work towards retrofits that are, one, deeply energy efficient, but also respond and enhance the urban and cultural fabric and are adaptable to current and future social needs. So with that, we're going to jump into 3 case studies. The first, Ashok is going to walk through the Lower East Side deep energy retrofits.
Thank you, Grayson. So yeah, a great case study here are 2 sister projects. It's located in the Lower East Side. These are two co-ops with 6 floors and about 12,000 gross square feet each. Next slide, please. So both these buildings, they look very similar, and they have exciting architectural as well as historic features. And this plays into the socioeconomic and cultural fabric of the Lower East Side. And so this is something that we do want to preserve. And as you can see from these photos, there are considerable structural as well as masonry damages. We found leaks in the roof. Additionally, these buildings at the time of renovation didn't have any centralized heating or cooling. There were no insulation in the exterior wall. They were also broken and missing windows. So this caused a lot of draft. It's understandably very uncomfortable to live in. And finally, there were multiple fires, so we also had to deal with the fire damages. Additional parameters that we work with are limiting our design as well as our solutions. So these include the fact that these are we have a fixed orientation, so we can't do anything about that. And the existing masonry wall will remain, and that's about 12 to 24 inch thick. And of course, we can't change windows around or block windows because everybody wants to have their windows to remain. And identifying not just the technical constraint, but as Grayson spoke earlier, understanding the unique socioeconomic context to help come up with the appropriate design solution here. Both the historic and cultural characteristic of these co-op add to the neighborhood's lexicon, which for us is something really important to preserve. So the scope of work here is complete rehabilitation. We couldn't use the wood joists in the building. It had inconsistent quality because of the fire damage as well. When we started looking into air sealing as well as insulation, it's a lot more challenging. So we decided to replace the floor, the joists, the roof, as well as the slab. We added new structural steel to support the new floors and address the deficiency in the masonry. So other goals we have here is to design it to Interfit Passive House standard. We also designed this building to the Enterprise Green Community Standard. The Enterprise Green Community Standard is a very comprehensive standard addressing addressing affordable housing projects. And it's a national standards, and it's just not looking at energy efficiency, but also indoor air quality, material selection, health, and so forth. So we've built it to the Enterprise Green Community Standard as well. Of course, we have to comply with existing building codes, provide healthy and safe space. And the goal of this project is to convert these cooperative housing to convert them into low-income cooperative housing. And of course, we see this as a model project for us and a project that everybody could learn from. So we also monitored the performance after a year of having continuous occupancy. So to better contextualize the limiting parameter in this project, we can take a look at the floor plan here. This is just a typical floor, and what we see in the center, where I shaded in yellow, is where the main staircase is located and basically the common space. So we had considered relocating the stair. So we have continuous interior insulation, an air barrier, but what we found is that it's really expensive to move the stair a couple of inches, and it presents a lot of complexity, adds to the budget. And at the same time, we don't want to put insulation on the outside because of the tenement characteristic and historic features of the facade that we want to preserve as well. We have some shared common walls with the neighboring building as well. So the other option may be to consider putting air and insulation layer on both the inside and outside, but this does cause some pretty complex transitions, especially it's going to create a lot of thermal bridge as well as make it difficult to get a continuous air barrier layer. So we abandoned that strategy. So the solution we came up with was to treat the public space, the staircase area, as a semi-heated space and treat the apartment units as a separate thermal envelope. So this way, what we were able to do by doing this was to provide a continuous air and insulation layer And we were able to get very crisp and simple detail, which helped in making sure we got a really good performing building. So for the air barrier, what we did is we took advantage of the fact that we're adding new floor joists. And we were able to put liquid applied air barrier first, and then 2 layers of rigid insulation, where the wall, where the steel joist walls meet the floor. We do have some thermal bridging here, as well as some complexity in the air barrier. But what we did here was we added insulation in the floor joist for at least 2 feet. And when we modeled it out, we found that it took care of the thermal bridge, and we added additional air barrier to make sure that it's airtight. So the next slide, we have some photos of this project after it was completed. We used triple pane windows and also installed the ERV system, a centralized ERV system. We did consider electrification, but because of the budget, what we did instead was we installed new and higher efficiency boilers for hot water as well as the heat. And there was no budget in this building for a centralized cooling system. So in this slide, we can see some of the interior shots. And one thing that's really interesting here is that 2 layers of masonry, which is about 12 to 24 inches, and then an additional 2 layers of interior insulation. It creates rather thick wall, but when we did speak to the occupants, one of the feedback we kept getting was that it was very comfortable. So you can also see in this slide the restored staircase that we did not want to move. So now Grayson will talk about a recently awarded project that our firm is working on through HPD's RFP in East Harlem. There's just one other slide I wanted to talk about, which is in terms of the benchmark performance. So about a year after the building was completed and occupied for at least a year, we did energy benchmark it. And we compared it to the average building that is the same size as well as the same type of use. And what we find is that, in terms of energy performance, we're in the top 5% in New York City. So I think that for us is very, very encouraging. So now I'll hand it over to Grayson.
Moving on to the second case study. This is the Beacon project. It's located in East Harlem. It's actually a very recently awarded HPD RFP. It's a project that we're working on. The developers are the community builders along with Ascendant Neighborhood Development. And we're part of a design team that includes WXY, Body Lawson, and Terrain. The program for the site is 250 new affordable housing and formerly homeless housing units and a new construction passive house building. That's sort of what you see in the back of the site there. Our role is not the design of the new construction. We are the passive house designers for that, but not the architects for that. Our role as architects is for the front of the site is this sort of adaptive reuse of an existing 6-story building, formerly a school, and 1-story vertical addition. In the RFP proposal, we pushed along with the developer to preserve the existing building. In our proposal, we spoke about embodied carbon, but we also talked about maintaining the architectural fabric of the site and of the social connection of the building's past use to the neighborhood and tying that into its future use as a community space. That advocacy, I think, was a deciding factor, or one of the deciding factors in the RFP award. And although the building is not a landmark, designated landmark, the building does serve as a defining node in the neighborhood. It's got distinguishing facade ornamentation. It's got grand massing at the entrance, and has just been a historical presence in the neighborhood dating to the middle of the last century. It's a rapidly changing city. It's a rapidly changing neighborhood. And so elevating and preserving this existing architectural stock is important to us in supporting the thriving heritage of the community. So in the retrofit itself, we emphasized several things. First of all, we want an interfit level renovation. Again, because of the historical significance of the building itself, that renovation is going to be done from the inside of the exterior walls, so we can maintain the existing historical detailing. Important note about that is in an RFP, you don't have a lot of opportunity to get in there and do probes on the existing building. And so we modeled out, with the help of the GC, a cost analysis of the worst case scenario where we would have to, assume that the existing structure is in terrible condition. We have to, support or replace most or all of it. And even in that case, it's cost comparable to a new construction building of the same size, but you do continue to get the benefit of the ornamentation and the historical significance of the building. Other key points is we want to leverage the value of the existing flexible layout for flexible layouts for the community center. And we want to amplify the usability and visibility of the building with the vertical glass addition that will hold a greenhouse, a gym, and multi-purpose space. As you can imagine, for a passive house building, a glassy roof addition is going to pose a technical challenge, but the increase in usability and presence of that addition in the neighborhood were important factors, and frankly, that approach was sort of needed to justify salvaging the existing building. Okay, just walking through some of the early design renderings of the space here. We're in that vertical addition. We're looking at a greenhouse that's used not only to grow food, but also as an educational space. Still up in that upper addition, here's a full-sized basketball court. Not shown in either is the multi-purpose spaces for flexible use for the community. Last vignette we'll show just really quickly is the entry of the building. To maximize usability, we are lowering the entry to grade for accessibility. We're also taking the existing openings and bringing them lower too, to increase visibility and transparency, sort of create that active street to inside relationship, where we'll have community spaces like incubator studios, youth action offices, and a community cafe. Okay, finally, here's a section perspective and detail of the project. So you can see sort of to the back, again, that new construction, affordable housing, and then in the front, our retrofit of the existing school building with the one-story addition that has the sawtooth window for solar. As I mentioned earlier, we will be using an approach similar to the Lower East Side retrofit as far as how we insulate and air seal the walls. We're doing from the interior, tying that into high-performance windows from the interior side. Of course, the roof will be new. It'll be new construction. And again, the sawtooth window with the solar. Just sort of to sum up our approach to this, we see the beacon, we're in the early design phases of it, but we see the beacon as a good example of the flexibility and remaining flexible when you have really diverse economic, social, programmatic, and cultural needs. Where possible, we want to find value in what's existing. We want to amplify that value and fix what isn't working. And when it's necessary, we want to build new. And no matter, in all of it, we want it to be sustainable and considering energy, architecture, and context. Last case study. So this isn't so much a project for a specific site as it is a conceptual approach to prefabricated deep energy retrofits that we expect to see growing in popularity, if not in the next couple of months, then in the coming years. So Retrofit New York is a program from NYC, and it's aimed to promote those prefabricated deep energy retrofits based on Energy Sprung. I expect many people are familiar with Energy Sprung, which quickly sort of, as part of this presentation, we'll quickly recap it. But the characteristics of the Retrofit New York approach are that first, we're focused on multifamily residential building. In our office, we focus even more on affordable housing. It's going to have a prefabricated wall panel with integral windows that are built off-site, of course, and trucked in and craned into place. It's going to have integrated MEP. And we want to get full building electrification as part of these retrofits. The idea is for it to be resident in place. And this is a good approach for that. But even in the best case, that can be tricky. We want to get integrated rooftop solar. the energy goal is net zero carbon. NYSERDA in their literature has stated that they're essentially attempting to create a marketplace similar to that found in Holland, where more than 50,000 social housing energy strong projects have been implemented. And NYSERDA sees the solution as a sort of a turnkey product-based solution versus what we're used to, which is, you know, design, bid, build. And so what we've been encouraged to do and what we are doing is integrating design, manufacturing, client interface, and GC/installation into one service. And that's intended to sort of set the market price, reduce inefficiency, and optimize results. So before we move on from this slide, just I'll quickly run through. This is a conceptual outline of how one of these would go together. So first, we have an existing building. We want to measure it. We propose to do that with digital surveying techniques. From there, we will build prefabricated high energy efficiency wall panels with integrated windows in a factory off-site. Before those are done, wall anchors will be installed all around the building. Any MEP services that need to run in branches and that can be run in branches down to the units will be run outside the building in a 4 to 8 inch service cavity. So refrigerant lines, small ERV ductwork. The panels, prefabricated panels, are shipped to site, craned into place. The utility, the ERV and HVAC are hooked up at the roof. Well, actually, the roof is installed first. High energy efficiency roof with integrated solar, and then everything's hooked up. And sort of the last step after everything's air and weather tight is you come in, you remove the existing window and heal that finish in that location. I think I mentioned the NYSERDA Retrofit New York program is relatively young. There have been a handful of completed Retrofit New York projects in the state. I believe Cycle Architecture is currently doing a pilot of a NYCHA renovation demonstrating this concept. And internally, we are working at this on a conceptual and schematic level, and also exploring the program with our clients with affordable market rate, but also working with professional partners to sort of build up a coalition and also think through the problem. And one of the problems is, what's the ideal case? What kind of buildings are we looking for? I would say NYCHA is, in many cases, an ideal candidate, NYCHA buildings, because what we're looking for are, first of all, freestanding buildings, if we can get them, with good access all around. You can imagine not only are you shipping in prefabricated wall panels from another location, but you need to stage them, you need to have space for a crane. We're also looking for buildings that aren't performing well energy-wise. This is not an insignificant investment, and so we want to make sure it's really decreasing energy cost to make it a valuable implementation. For the same reason, we're also preferencing affordable housing. We think this can really improve long-term affordability. We're also looking for buildings without intensive architectural ornamentation. So obviously, wrapping a landmark building and a new energy efficient facade, that's a non-starter. But even non-landmark buildings, we want to preserve historic character where we can, A, and B, cornices and window details can complicate the overclad solution. Same with fire escapes as well. So from the MEP's perspective, in the perfect world, we'd have buildings that have kitchens and baths with exterior windows. We've looked at a dozen or so case studies, and maybe one of them had that condition. So it's not something we're expecting to see on most buildings. And so in those cases, we'd be looking either at unitized solutions, so heat pump PTACs basically, and maybe unitized ERV, but also looking at potentially taking over, repurposing existing vertical shafts, or taking over some space in closets to run vertical ductwork to pick up the returns of the ERVs for bathrooms and kitchens. Whenever I did just mention the sort of PTAC, high performance heat pump unitized solution, we would look for buildings, if we're going to put those in, that already have AC sleeves or something below the window that already has that opening that we could utilize. sort of the last slide here is a conceptual detail of what this might look like, starting on the right with the existing condition. This, all the buildings are going to be different. This was a NYCHA building we looked at. We had a section of essentially a concrete structure with a 4-inch masonry wall backup and 4-inch brick veneer, no insulation. We expect oftentimes to have no or low insulation. From there, we're going to, of course, as I mentioned, we put in our anchors, and then the high performance prefabricated wall panel comes in this case, a mineral wool based one, is sort of secured in place. The next one goes on top. There's a double redundant air and water seal, all gasketing all around. In this case, we are insulating the roof traditionally with 8-inch polyiso pitched to the drains, insulating the parapet, providing a new railing. And then finally, on sort of the left there, you can see the condition where we have this MEP service cavity. We have some small ductwork and refrigerant. So the manufacturers have a anchor detail that allows us to go out up to 8 inches to accommodate that. And so then once that's in, we'll remove the existing interior window and then place in the finish around that jamb. One thing that we're thinking about is, okay, we're putting all this service refrigerant lines and ducts outside the envelope, but behind these prefab walls, how are we going to get to that if there's an issue later? And sort of one thing we're thinking is through this sort of window jamb. Okay, so that is the sort of the end of our presentation. But before we take it over to questions, I just want to wrap up and circle back to earlier questions about how these buildings fit into the urban and social and cultural fabric, because I think Retrofit New York is a tremendous opportunity, and we could really see it take off. And with that opportunity, there's also a lot of responsibility on the design side. And so one is aesthetically. So if I imagine this sort of implemented at scale within NYCHA buildings, that's a huge change to how we see our city. And the way we see it, the way to tackle that problem, or one of the tools to tackling that problem, is to use resident engagement-based design practices. So you can imagine each building being a direct response to the aesthetic and cultural values of the people who live there, which is obviously beneficial, but also creates diversity and uniqueness between the buildings. On the energy and carbon level, we're obviously committed to passive house energy standards. We also want to do it with careful selection of materials in consideration of embodied carbon life cycle and durability. We want the renovations to be easily maintained, but also we really want to exceed by a good bit the 30-year minimum life cycle called for in Retrofit New York. And just finally, we're excited to continue to collaborate and learn from other designers, manufacturers, and engineers, from our colleagues, from you basically, and developing and improving these solutions. And we thank everybody for your time, and appreciate you listening, and happy to answer some questions.
Yes, thank you, Grayson and Ashok, for that presentation. Personally, at Stephen Winters, we don't do a lot of retrofits, so I learned a lot from this, and I'm sure a lot of people did. There was some great discussion going on in the chat. I will say, for questions, you can either write your questions in the chat, or if you have a long or more complicated question, feel free to raise your hand, and we'll go ahead and unmute you when it's your time to ask the question. But there was a question earlier from, I believe, Kate, that we said we would circle back to. So Kate had a question in the chat. First off, she said, I really appreciate your approach and appreciation for maintaining the social and architectural integrity and preservation of these buildings. Have you completed any projects on New York City landmarks or buildings that are in the NYC historic district, which have more stringent requirements for exterior windows, etc.? And for these, do you find that historic buildings basically need to be gutted in order to reach this level of energy performance?
Great question. Great questions. The first answer is yes, we have done similar to the Lower East Side retrofit specifically that Ashok shared. We've done similar renovations to landmark buildings in landmark districts, not individually landmark buildings. And there are more stringent requirements for the windows. And the one that I'm thinking of specifically, it was we're replacing double hung windows with casement windows. And so we are sort of standing on the shoulders of passive house pioneers before us who sort of fought the battles and also got the windows approved for the casement windows that kind of look like double hung. They're sort of, there's the casement is set back, so there's a shadow line. And we use those windows, and it wasn't hard to approve because Landmarks is used to seeing those by now. I think it's a little bit, it kind of narrows the field of possible windows, but that's any landmark project, energy efficient or not. And so that raises the cost a little bit. As far as what's the level of renovation, do you have to do a gut renovation? I mean, it certainly helps. You got to get down to the air barrier layer at least. So, and preferably you're doing it all at once. But we do have clients who have bigger buildings who talk about phasing. I mean, you could conceive of a scenario where you sort of did some of this apartment by apartment, but I think at least a heavy moderate to gut renovation would be needed because you got to get to the existing masonry, and you got to replace the air barrier, you got to replace windows. You're going to be enlarging the interior walls a little bit, and that's going to have a little bit of an effect on the interior space, kitchens and bathrooms especially. So yeah, I think maybe more thought needs to go into it, but my first answer is mostly yes, you need a gut renovation. I don't know if Ashok, you have a different thought on that.
For the time being though, Ashok, I know you were answering a lot of questions in the chat. I'm not quite sure where you ended off at. So I don't know if you want to continue with some of the questions, or I can just kind of go down the list. Sure.
There was a couple of questions I did wanted to, generally one of the questions I got in the chat was in terms of the lower east side project, if it was passive house certified. So the answer to that is no, we did not get passive house certified because of budget constraints. But what we did do was modeled and optimized a building to the passive house standard, and we worked very closely with the owners and the general contractor to make sure that everybody was on the same page. And we also increased the number of visits we did to the site and inspection. So what we find really encouraging here is that passive house certification is great, and there's a lot of plus for going for it. And it's about hitting a certain performance requirement. But projects like the Lower East Side also shows that the passive house delivery process in itself is very valid and a great way to get to our decarbonization goal, even if we're not certified. And that was something that we were able to confirm with our monitor result, where we were in the top 5% in terms of the energy performance, but also when we look at the monitored result and compare it to our energy modeling, where we use Wi-Fi passive, we also found that the performance was within 10%. So that's the answer, sort of like the question around passive house certification and quality control without getting it certified.
I also saw a question in here about the panelist. I apologize if I'm moving around. I think it's a good question. It's from T. Piscopia, and the question is the panelization version, is it cleat or green girt being attached to the building exterior scan and connected to the concrete exoskeleton? And the answer is there's a kind of a cleat. It's an anchor. It's an anchor. Different manufacturers actually have different solutions to it, but yeah, but it's not a green girt, importantly, because in this scenario, the entire thermal envelope is shifted outside of that attachment. And so like our high performance prefab walls are to the outside of that anchor, and that anchor is completely on the inside. It's metal, and it's attaching to the backside of the panel, which is thermally broken at that condition. So hopefully that answers the question.
Yeah, there was another question related to the prefab panels. How are the panels constructed and attached to avoid thermal bridges? Certainly can't use metal framing, can you? So I believe, Grayson, you did just answer that as well.
Yeah, Well, you could use metal panel. We've seen a couple of different solutions. So we've seen at least 3 good solutions. I would encourage, just going to shout them out by name. I would encourage folks who are interested to look at Trimco, Dextol, and RC Panel. They all have slightly different solutions. I don't know how much of it's on market. I don't want to get into too much detail and give away their secrets, but you could do metal stud if you wrapped it like you would a metal stud panel wall with insulation, but you're probably better off with a thermally broken sort of structural component, which they do have. So I'm sorry I can't answer too specifically because I don't know exactly where they are in releasing these things in the market, and I don't want to like give out secrets that I'm not supposed to.
Another question, I believe this also relates to the panels. How thick is the wall panel plus the ductwork? Aren't you limited to 8 inches by zoning if on the property line?
Yes. So the last question first. You are limited to 8 inches by zoning, even if I guess you are limited to 8 inches by zoning. And theoretically, you're limited to 8 inches on zoning even if you're not on the property line, but if you have the floor area, it's not going to matter in the lot coverage. But it's sort of circling back to earlier in our presentation. That's one of the other reasons we're looking for freestanding buildings that you have access to on all the sides. Once you start getting to lot line conditions, it gets a lot trickier. Like, so even if you're 5 stories, you have a 1-story neighbor, you're a 6-story building, like you're still like getting the permission to hang over their lot line condition is going to be problematic. And so overcladding in that case may be tough. How thick the wall panels are, they are about 6 to 8 inches. And so that's most of that allowable zoning. And then you're going to want another 4 inches clear at least for that mechanical condition. And so, if you have a zoning problem, you could do a couple things. You could then up the panel in those locations where you have those chase conditions. But I also think collectively we should, be advocating for this exception to be reconsidered for the retrofit case.
All right, thank you, Jason. So at this point, I'm just going to go down the list of questions in no particular order, other than first come, first serve. So Jose asked, who is sourcing your windows for the retrofit and landmark projects?
Ashok, unmute yourself. I don't want to take all the questions. I'll take this one. A variety of window manufacturers. So
I was going to say, and there's a lot more coming on the market now. Now that energy efficiency is starting to finally pick up.
All right, the next question, Ken asked, outside of New York City, there are millions of wood-framed houses. Any thoughts on how to approach those?
So what we're seeing is that, there is, I believe it's called cost-laminated timber, which is allowing us to build a lot better with wood. It addresses a lot of fire issues. And we like that because it does kind of come into the, it does address some of the embodied carbon issues. But one of the challenges that we're seeing is that one is in terms of the code where they're not necessarily updated to meet like the fire requirement. And, when we also start talking with clients about these buildings or using wood or preserving the wood, the first thing they think about is fire, and it kind of pushes them away from that idea. So I think we're seeing a lot of projects that are using wood, large scale projects that are also energy efficient. And I think we're probably going to see a lot more of that in the coming years.
I'm going to add on to that. The question also seemed to indicate maybe single family wood frame houses. I think, and if that's the case, I think I'm not sure that the Retrofit New York overclad solution is a great fit for that. It may be. In my research of what's been done in Europe, it's been larger buildings, and that makes sense. Like, kind of want to, you're mobilizing. It's a pretty big undertaking. You're mobilizing a manufacturer and a GC. So the bigger building, you're going to get economies of scale. So for single family homes, I'd probably consider a different approach, at least initially, and maybe as the technology matures, sort of single family products will come on the market.
And another thing I wanted to add about the wood, especially when we're looking at newer construction, is that in some places, for example, in West, you know, your wood source could come directly from your local region. So that also cuts on sort of the embodied or the carbon release during transportation and stuff like that. And you know, one of the things we're seeing also is, you know, for public buildings, we're seeing some states like that saying like, you know, we use wood because we have a lot of wood and we are regulating the forests that we're getting these woods from, so we could consider it also renewable. So that's another great angle to think about when thinking about wood construction.
The next question, Ashok, I believe you answered this in the chat, but I would love to, you know, get this on the recording. So are there recommendations for interior air sealing and compartmentalization retrofit when retrofit is resident in place?
Yeah, I mean, what we typically find is the important thing is really to look at the details and also to work them out, think about things like sequencing, like construction sequencing, make sure that they fit in really well. And one of the ways we do this is also to get feedback from the general contractor and work through these details as well. And I think like that presents a big chunk of solving that issue. And the second thing would be on site, making sure that you know, these strategies are being built as you're designing. So where we really find where we want to focus are those small junctions, like where your window meets your wall, and make sure that everything is continuous. So that's sort of our, I guess, high level strategy for it.
Yeah, and then the resident in place portion of that's tough on the interior air barrier. And if you're considering that, you're as Ashok said, your GC really has to be a partner, and you're going to have to start thinking about, I mean, you're going to be taking, it's probably consider like moving residents around within the building potentially. It's going to be tough to get down to that level of renovation. Could be done, but you're going to be talking about hospitality suites, about moving people in vacant apartments, maybe moving them out during the day, moving them back out in during the evening, that kind of thing. That's one of the benefits of the overclad retrofit New York. All that gets taken in from the outside face.
Circling back a bit to embodied carbon, the next question is, embodied carbon accounting for some determined time period, 2030 to 2040, will be important to how deeply we should retrofit. Do you all have any thoughts?
Yeah, so I could try answering this. And there's another question that follows this where it's looking at NYSERDA and pushing for state policy. Generally speaking, what we see is that we have a lot of standards that cover operational carbon, but there's really a lack of not just standard, but also the literature in terms of understanding how the carbon emission is accounted for in terms of, say, transporting the materials, taking the materials out of site, but also the energy used on sites and stuff like that. And one thing we notice is that you know, there's only a couple of materials that we can focus on to drastically reduce that embodied carbon. So for example, when we look at our projects, what we consistently see is that the insulation, the steel and concrete is what is driving the embodied carbon in a building. I'm not like 100% sure what that percentage is, but it's pretty high relative to the other things. So if we were to, you know, if we were to look at policies, or if we were to just go to our GC and say, you know, this is the specs we want for a concrete, but we want you to use a lower embodied carbon material, then that would be like an easy fix where we would be able to considerably make an impact on that embodied carbon. The thing though right now is that we don't have the policies, we don't have the, you know, we do have some sort of calculation methods that are there, but we don't really have it in the way where passive house is really well understood. And this is something we really hope to start seeing in the coming years, a really strong focus on the embodied carbon, because like we mentioned earlier, everything we're doing now, yeah, it's great because we're going to reduce the operational carbon, but that embodied carbon is being used up right now, and there's nothing really we can do about it. So it's really great to find ways to make sure that we're not going to retrofit 90% of New York City by reducing the operational carbon, but adding a ton of embodied carbon that offsets it.
Great, thank you, Ashok. So next question, can you talk more about your decision around various insulation technologies, integration with the air vapor barrier, and thinking around carbon footprint, recycling potential, global warming potential for various insulation materials?
Sure, I'll take the first stab there, Ashok, and you'll correct me. So just rewinding to, let's look at Lower East Side. So thinking about, I think Ashok did a pretty good job actually about talking about how where we put the air barrier and why we put it there. But there's also part of it is practical, constructible, economical. And so, you know, we we're working with the GC first of all, and we're speccing a pretty easy to install air barrier, trowel on or paint on air barrier. That's going to be not too expensive, that's going to work well, and that the contractor is going to be comfortable with. At that time, that was pre like EC3 for us. We were, you know, mineral wool was the preferred insulation. It's fireproof, resistant to water, and we would just try and get it in wherever we could, as opposed to a plastic-based insulation. For newer projects, to sort of answer your question, that especially the insulation products and also any structural products will be, you know, we're getting into EC3 modeling, and we'll be able to compare mineral wool to maybe another product spec to see what the embodied carbon is, and that will inform the decision making. And I'm not sure that I've answered all the questions, but I answered all the questions that I can remember.
Yeah, I believe so. We've done a lot of talk about embodied carbon and carbon emission and carbon footprint. So I think that's been answered, but Nathaniel, that is your question. So if you have any follow-up, please let us know in the chat, or feel free to raise your hand. We do have another follow-up question on the panels. Seems to be a hot topic today. So a little context, my understanding is the weight of the panel needs some structural connection to the concrete frame behind the masonry cavity wall, or is the panel engineered very lightweight? How much do the wall panels weigh, and what size do you propose?
Yeah, the structural connection is important. They are lightweight. They're going to vary, and I don't have it in front of me, the PSF, but they're going to vary depending on the manufacturer, but they're all designed to be lightweight. And I think when we're looking at, and they're also going to have different, it's not always going to be concrete. Sometimes it's going to be wood joist that you're connecting to at the floor line. But they're designed to do that. And I think from a starting position, you're going to be in pretty good shape for the weight. You know, in your 5, 6, 7, 8 story building range. When you start getting to the 20-story building range, it's not so much the weight of the panel, but like the wind loading is going to influence that structural connection. And you're going to need a sort of another level of review and detailing to make sure that your attachments are secure. And I'll just, again, shout out the 3 manufacturers we're looking at who can give more details on their products: Trimco, Dextol, and RC Panel.
Great, thank you. And I believe we have 1 or 2 more questions. So for the Lower East Side renovations, I believe, where did the co-op tenants go during your renovations?
Wherever they wanted, they were given a stipend. You know, some people relocated. One guy lived in a van and pocketed the money. And yeah, that was, yeah.
I like it. And the last question, which Ashok, I believe you just answered in the chat, but just again, so we have it on the presentation, what software is utilized to quantify embodied carbon?
Sure. So there's a software called the Embodied Carbon in Construction Calculator, EC3 tool. This is a free open software. And basically what you're doing is you're doing a lot of takeoff and looking at materials. And like I said before, you know, it might sound very daunting to like quantify all the materials used, but if you're just looking at something like concrete, steel, and insulation, then through this calculator, you're able to evaluate, how much of a savings you get in terms of embodied carbon just by, swapping, for instance, concrete with a low embodied version of the concrete. So your performance doesn't change, your price doesn't necessarily change, but you do have a big impact. So again, that software is called Embodied Carbon and Construction Calculator, and it's a free tool to use.
There's also somebody just put in the chat, EC3, Tally, and one click. I've heard of Tally, but not one click. Alicia, I think it sounds like we're wrapping up here, but I just wanted to, there's a lot of good comments in the chat that I didn't get to get through them all. Is there a way to preserve them so we can circle back later?
I will definitely have to ask Andreas, but you are absolutely correct. There's been a lot of good discussion here. So we'll see what we can do as far as preserving those and distributing them to yourself and with the rest of the participants today. I want to say thank you, Grayson and Ashok, for joining us, and for Paul Castrucci Architects for again being a sponsor of the New York Passive House. Thank you all again for joining. Have a good rest of your Thursday.
Thank you.